For this section, I would like to teach you on how to define the term isoelectronic and how to compare the radius of isoelectronic species. Okay, so what is isoelectronic species? Iso maksudnya sama, elektronik adalah electrons. Okay, so isoelectronic species ni ialah kalau let's say atoms atau sesebuah ions tu dia ada sama electronic configuration dia, they are known as isoelectronic atoms or ions. Okay, kalau isoelectronic series pula is a group of atoms or ions yang ada sama number of electrons. Okay. When we talk about isoelectronic species, we are talking about a group of atoms or ions yang mempunyai electronic configuration yang sama. So sebagai contoh, if you look at here, fluorine atom, dia punya electronic configuration dia 1s2 2s2 2p5, tapi bila jadi fluorine negative ion dia akan ada electronic configuration of 1s2 2s2 2p6. Okay, for sodium atom, this is the electronic configuration of sodium atom, but when sodium jadi sodium positive ion, dia akan mempunyai electronic configuration just the same as F minus. Okay, same goes to oxygen 2 minus. Bila let's say oxygen atom receive 2 electron, dia akan mempunyai electronic configuration sama macam Na plus and also F minus. And is same goes to Al3 plus juga. Bila Al atom dia donate 3 elektron, makanya dia akan mempunyai electronic configuration sama dengan F minus, Na plus and also O2 minus. So because although these ions dia berbeza-beza ion dia, okay, seorang negatif, seorang positif, tapi dia punya electronic configuration dia sama kan. So that is why we call it as isoelectronic ions, okay, because those ions ada electronic configuration yang sama, okay. And also they are isoelectronic with neon, sebab neon atom ada 10 electrons, okay. Regardless, they are isoelectronic ions. Alright, just now, before this, we have discussed about the size of ions, size of positive ions dengan size of negative ions, right? Size of cation ion sebab dia remove electron, that's why size dia kecil. Kalau size of anion sebab dia accept electron, that's why size dia besar. Do you get what I mean? So the same thing goes to the variation in radii, in size of isoelectronic species. In isoelectronic series, if let's say the more positive the charge, the smaller the species, the more negative the charge, the larger the species. Okay, kenapa Miss cakap macam tadi? Okay, so kalau across the third period, if let's say across the third period, the more positive the ions, the charge, okay, makin lama makin increase kan across the third period dia punya charge. The smaller the species, okay, itu yang Miss masukkan. They are isoelectronic series. Sebab kenapa? Bila Na plus jadi je ion Na plus, Mg2 plus, Al3 plus, tiga-tiga ions ni adalah isoelectronic ions because they have the same electronic configuration. So because diorang ada 10 electron, so the number of electrons ada 10 untuk ketiga-tiga ions ni, okay? Same goes to isoelectronic ions in second period. Bila N3 minus, O2 minus, F minus, bila diorang jadi ions, they have the same electronic configuration, which results in the same number of electrons. Okay, so if you look at the second period, the more negative, okay, makin ke atas makin negatif kan, the more negative the charge, the larger the species. Okay, and all of these ions semua ni adalah isoelectronic ions, okay, sebab diorang ada same regardless dia positif ke negatif ke, berapalah charge dia, 2 positif ke 3 positif positif ke atau 3 negative, 2 negative, 1 negative, regardless of diorang punya charge, they are ions. Kan? Cation ke, anion ke, they are still ions. Right? So that's why bila diorang jadi ions, they have the same electronic configuration. Therefore, they are isoelectronic species or isoelectronic series, which they will have the number of electrons bila diorang jadi ions 10. So all of the ions are isoelectronic with neon atoms. Okay. Now, let's analyze the variation in the ionic radii across period 2 and period 3. In case if you are wondering, period 2 in the periodic table of elements, okay, so that is the location for period 2 in the periodic table of elements. Sekarang ni, kita akan analyze the trend of the size of ion, okay, bukan atom tau. Kalau atom kita dah discuss kan before this, kalau across the period makin lama makin mengecil, tapi ada different trend in the ionic radii. Okay, kiranya kalau di period 2 ni dia ada ion masing-masing, mereka ada different trend in the size of the ion across period 2. Okay, let us start our discussion in the variation in ionic radii ataupun kepelbagaian size of ion across period 2. Okay, so these are all the elements across period 2 in the periodic table of elements, which we have Li, Be, Bc, NOF and also Ne. Okay, so kalau diikutkan Li, Be, B dan C, diorang lagi suka nak buang elektron. Okay, so bila diorang buang elektron, makanya mereka akan dapat positive charge. Okay, so if you look at the trend of the positive charge from lithium to carbon, okay, lithium akan lose 1 electron, carbon akan lose 4 electron. Okay, so obviously semakin bertambah positive charge, semakin apa? Semakin kecil. So kalau if you look at this graph, okay, memanglah proton number bertambah kan across the period. Tetapi kalau ikutkan ionic radii, ikutkan size of ion tersebut from Li sampai C, carbon have the smallest have the smallest ion punya size, ionic size. Sebab apa? Semakin bertambah positive charge, semakin kecil size ion tersebut. Okay, so across the period, size of, tak kisahlah kalau let's say cation ke anion ke, tapi kalau across the period, we already know that the size will be decreased. Tak kisahlah size tu cation ke anion ke, dia akan berkurang. Okay, tapi I would like to analyze the cation first lah. Okay, and the proton number memanglah increase, but the number of electrons sama sahaja. Okay, and they are all isoelectronics. Okay, sebab bila dia jadi ion, semua jadi isoelectronic. Therefore, the ZF akan increase and cause the ionic radius to decrease. Okay, senang cerita lah dalam periodic table of elements dekat chapter 3 ni lah kan. Kalau let's say you tahu size of atom tu mengecil, you guna je reason ZF, reason effective nuclear charge. Okay, sebab kalau let's say effective nuclear charge increase, you will know that the attraction between nucleus and also outermost electron, the attraction dia stronger. So bila attraction dia stronger, maka dia suka nak mengecil. Okay, so bila size satu size species tu, dia kalau let's say size dia kecil sebab ZF increase. Okay, so kalau kamu nak susun ionic radii for cation in that in this table, you boleh susun Li plus paling besar, C plus paling kecil. Alright. Next, I will talk about the size of the anion here. Okay, kan anion memanglah slightly bigger than cation. So that's why lah anion ke atas sikit lah graf dia berbanding dengan Li+. Alright. So across the period you akan guna jugalah reason yang sama. Cation ke anion ke size dia memang decrease. Okay. Alright. So from N to F, ZF increase. Hence the ionic radii decreases from N to F. Okay. And the electronic configurations mereka sama sahaja. Okay. They are all isoelectronic. So if you want to susunan of the ionic radius, you will have to start from N3 minus, because N3 minus is bigger than O2 minus and O2 minus is bigger than F minus. Okay. Sebab apa? Daripada N to F, proton number increase. Bila proton number increase, ZF increases. Bila ZF increases, ionic radii decrease. Macam itulah cara kamu nak terangkan. We all know that cations have smaller ionic radius compared to anions within the same period. Walaupun diorang berada dekat same period, whatever it is, the size of cations will always be smaller than anions. Okay, sebab anions, kenapa size of anion ni lagi besar? Sebab anion ada larger screening effect. Size cation kecil sebab apa? Sebab ZF. Okay, tapi kalau if let's say you nak explain the trend kenapa N sampai F ni size dia kecil, sebab ZF increase. Okay, tapi kalau you nak explain between the size of cation dan anion, kalau you nak explain the difference between them, you have to say anion size dia lagi besar daripada cation sebab anion dia ada larger screening effect. Okay, sebab anion ada larger shielding effect. Okay. So how do you say so? Okay, so contohnya Miss nak compare lah between F minus dengan Li plus. Okay, kalau F minus, because dia accept one electron, so that's why dia akan jadi 1s2 to s2 to p6. Li pula, because dia remove one electron, makanya dia akan jadi 1s2. If you look at here, the valence, the number of valence shell untuk F lagi banyak daripada compared to Li. Okay, and F minus dia ada inner shell. Okay, bila dia ada inner shell, makanya shielding effect dia pun akan lagi bertambah. Okay, so that's why kalau you nak discuss about the trend, macam mana you nak susun size of the ions across period 2, you have to start with N3 minus, and then barulah you kena start with you habiskan anion dulu. Sebab anion size lagi besar daripada cation kan. You start daripada anion, barulah pergi kepada cation. Alright, so how do you explain about this big jump? Tadi kita dah bincang pasal the trend of ionic radii secara keseluruhan, tapi how about this big jump? This big jump occurred because from cation kepada anion kan. So you nak explain macam mana? You boleh explain melalui these two reasons. The first one, you can say that N3 minus ada more number of shells compared to C4 plus. Therefore, N3 minus has greater shielding effect. Okay, and the second one, you can say that N3 minus is an anion, and you always know that size of an ion is always bigger than C4 plus, that is a cation. Next, we will be discussing about the variation in ionic radii across period 3. Okay, so if you are wondering where is the period 3 in the periodic table of elements, so these are the elements in the period 3 of the periodic table of elements. So kita akan discuss mengenai size of ion untuk setiap elemen di period 3 in the periodic table of elements. Alright, so these are all the elements in the period 3, across period 3 in the period table of elements, starting with Na and with Ar. Ar adalah argon, okay? Tapi sebab Ar is a noble gas, sebab the noble gas dia dah mencapai octet, therefore we will not discuss Ar. So we will discuss only up until Cl, okay? Sebab Cl nak jadi octet kena receive 1 electron kan, so that's why dia jadi Cl minus, S2 minus, P3 minus. Okay, sebelum tu akan jadi cation untuk mencapai octet punya configuration. Na has to lose 1 electron, therefore Na will be Na plus, okay. Mg2 plus, Al3 plus, Si4 plus. Okay, so kalau ikutkan skema macam biasa, you kena terangkan dulu across the period, tak kisahlah dia cation ke dia anion, the size of the ions will decrease, okay, akan berkurang. The proton number memang ada increase in the proton number, tapi the number of electron is still the same. After diorang jadi ion, the number of electron will still be the same, okay, and there will always, all of them akan ada isoelectronic. Diorang akan mempunyai electronic configuration yang sama selepas mereka jadi ions, okay, which walaupun jadi Na plus ke, Mg2 plus, Cs2 minus ke, Cl minus ke, there will always, they are all are isoelectronic species which dorang ada same electronic configuration, which is 1s2, 2s2 and 2p6. Alright, okay, first of all kita cakap dulu apa yang berlaku dekat cation. Yang ni adalah general statement, okay. First of all bagi tahu dulu apa yang berlaku dekat cation. Cation, okay, memanglah although that walaupun proton number semakin bertambah, ZF increase, right? Tapi one of the reasons why cation size dia berkurang sebab apa size dia berkurang? Size berkurang sebab ZF increase, okay? Cation size dia berkurang sebab the effective nuclear charge increase, and therefore dia akan menyebabkan ionic radius akan decrease, okay. So if you nak susun ionic radius for this cation, it will be Na plus will be yang paling besar, and then Si4 plus akan jadi paling kecil kan. Semakin bertambah positive charge di dalam isoelectronic species, semakin kecil size dia kan. Alright, next, if you nak cakap trend of this anion from P sampai Cl, kan P3 minus makin lama dia punya size makin kecil kan. Okay, kalau you nak cakap within this anion juga, kenapa daripada P3 minus sampai Cl minus makin lama makin kecil size dia? Sebab you boleh guna juga because the reason why, because from P to Cl, the number of proton increase, therefore the effective nuclear charge will be increased, hence the ionic radii decreases. Alright, diorang ada same electronic configurations, but if you nak susun the size of the ions from P3 minus to Cl minus, it will be P3 minus, S2 minus, Cl minus. Okay, senang cerita, kalau let's say you nak compare compare between anion dengan anion, you will know that kalau let's say dia turun ke bawah, the size will be increased, the size akan jadi decrease. Bila size dia berkurang, makanya sebab kenapa size berkurang, you boleh relatekan dengan effective nuclear charge because the ZF increase. Okay, next, kalau let's say you nak compilekan, you nak susun all of the ions across period 3, okay, barulah you kena compare between cation dan juga anion, okay. So you can say cations have ionic radius kecil daripada anion. Sebab apa? Anion ada larger screening effect. Okay, so if let's say you buy electronic configuration between Na plus and also Cl minus, you can see that Cl ada extra shell compared to Na plus. Therefore, Cl ada larger screening effect. That's why lah an ion saiz dia besar daripada cation ion. Tapi bila you nak susun the trend dia punya full trend, okay, you kena susun an ion dulu, baru cation ion. Okay, kalau let's say you susun between an ion, you know that daripada P ke Cl, Zf increase. Therefore daripada P ke Cl, saiz dia pun makin mengecil. Okay, tapi bila let's say you nak compare between cation ion dan juga an ion, you boleh cakap mengenai shielding effect. Sebab apa? P3 minus ada more shell compared to Na plus. Okay, so that's why lah after you susun an ion, you susun lah between cation ion, and you tahu kalau cation ion makin bertambah, positive charge makin kecil species tersebut. So that's why Si4 plus will be the smallest species, the smallest ion in period 3. Next, how do you explain about the big jump between this cation ion and an ion? Okay, you boleh bagi tahu ada dua sebab. Sebab yang pertama, P because dia ada more shells, that's why shielding effect dekat P ni bertambah. Because shielding effect dia increase, therefore size of P akan lagi besar daripada size of Si4 plus. And also you can say that P3 minus is an ion. That's why dia besar daripada cation ion Si4 plus. Okay, so roughly kalau let's say you ada diagram yang menunjukkan variation in ionic radii in the periodic table. Tadi kita just discuss pasal trend of ionic radii in period 2 and period 3, right? So this is how it looks like. Okay, cation ion will always be smaller than an ion. Okay, so that's why you start with N3 minus, O2 minus, F minus, Li plus, Be2 plus, and so on. Okay, same goes to period 2. Cation ion akan always be smaller than an ion. Tapi and then you will always know that down the group size akan bertambah, across the period size akan berkurang. Tapi kalau let's say if we are talking about ionic radii, about ions, it will always be an ion always be bigger than cation ion. Okay, to conclude almost everything, it is safely said that the size of an atom, kalau atom bukan ion size of an atom will always depends on the electron cloud. Macam mana you nak tahu electron cloud tu? We are talking about the attraction between nucleus and also electron. So kalau let's say we are talking about the average distance of valence electrons from the nucleus. Kalau let's say valence electron tu jauh daripada nucleus, makanya size dia akan besar ke kecil. Macam tu lah. Kalau let's say distance dia lagi dekat, distance of the valence electron dekat dengan nucleus, makanya electron cloud dia mengecil, therefore size of an atom tu akan jadi kecil. Okay, and the size of an atom akan depends on 3 important factors, which is about electron repulsion. Because kalau let's say ada electron repulsion, therefore dia akan menyumbang kepada shielding effect. Shielding effect akan buatkan atom tu bertambah besar. Okay, if let's say the ada attraction between, bukan repulsion tau, tapi kalau ada attraction, if ada attraction between nucleus and also electron, dia akan menyumbang kepada factor effective nuclear charge increase. Okay, so therefore dia akan buat the atom bertambah kecil. And also one of the important factors yang memainkan peranan kat sini ialah principal quantum number. Sebab kenapa? Because if let's say the number of shell, if n increases, dia akan menyumbang kepada shielding effect, kan? So if N increase, shielding effect will be increases. Therefore, dia akan buat atom tu larger. Pokok pangkalnya, dia akan depends pada actually dia akan depends pada dua faktor saja, which is shielding effect, okay, and also effective nuclear charge. Kalau shielding effect, apakah yang menyumbang kepada shielding effect? Kalau let's say electron repulsion and also the number of shells. Kalau number of shells bertambah, shielding effect bertambah. Kalau ZEF pula, kalau ZEF, factors yang menyumbang kepada effective nuclear charge adalah attraction between nucleus and also valence electron. Okay. Kalau attraction between nucleus and valence electron bertambah, makanya effective nuclear charge pun akan bertambah. And you need to remember, kalau across the period, in the periodic table of elements akan bertambahlah, there will be more proton, therefore there will be more attractions between nucleus and also valence electron, maka dia akan menyumbang kepada ZF. Okay, ZF pun akan meningkat, therefore the size will be smaller. Kalau down the group, the number of the shell will be increases, therefore the electron will become further from the nucleus, and dia akan menyumbang kepada shielding effect. Okay, shielding effect akan bertambah. Therefore, the size will be larger. And kalau pasal ion pula, if let's say if it's a cation, dia akan carry positive charge. Kenapa dia carry positive charge? Sebab the atom lose electron. Bila atom lose electron, dia akan dapat positive charge. And therefore, there will be less repulsion. Bila less repulsion, therefore, dia akan menyumbang kepada ZF. ZF akan, effective nuclear charge akan meningkat. So, bila ZF meningkat, the size of the ion will be small. Okay, kalau N ion is because the atom gains electron. Bila dia gain electron, the repulsion between electron akan increase. So, dia akan menyumbang kepada faktor shielding effect. Okay, so bila shielding effect increases, therefore the size of the ion will be larger. Okay, so that's all I think untuk 3.2 A and B, C, D, E and also F. Okay, so I hope that you faham lah dengan explanation Miss. Kalau tak faham boleh ulang balik video. And next, Miss akan bincang pasal examples or some questions yang melibatkan 3.2 A until F. Alright.